Today we will begin with a new topic on coastal water level fluctuation. Tidal measurement in the coastal region typically is measured using a float steering well, whereby it is made out of a vertical column with an orifice so that the water level inside the column is the same as the water level outside, whereas the inside is protected from wave action, the short period wave. The float rise and fall according to the change in water level to activate the pulley so that it gives us a record of the water level changes. In Peninsular Malaysia, the leveling network was first established by the British, known as the Land Survey Datum in 1912. This is based on tidal observation in Port Klang over a period of only 8 months. And as a result of that, it has limited accuracy and number of witnesses. Subsequently, as the technology advances, Malaysia has moved forward and established the new National Geodetic Vertical Datum, or NGVD, for Peninsular Malaysia. Under the NGVD, the first order precise leveling has been carried out, and subsequently, using 10 years of tidal observation between 1984 to 1993, Japan has established the revised mean sea level reference for the Peninsular Malaysia. And also based on this new datum, this monument in the headquarters of Japan, Kuala Lumpur, has also been built, giving the exact location of the datum for reference purpose. So subsequently, all the measurements, land survey are based on this NGVD system, although the land survey datum is still being used as well. This table here shows example of the NGVD and also the land survey datum for Kedah Pier. In this case, the NGVD and the LSD value are the same. And of course, the local chart datum is different. As you notice here, for example, the chart datum in Kedah Pier has a 0 at this particular level. So subsequent measurement, local measurement of the tidal water level is in terms of chart datum, and so the necessary conversion must be made. So in all marine construction, accurate conversion between these LSD, NGVD, and also the chart datum is very important, so that the engineers does not make any unnecessary mistake in terms of the water level and also the platform levels in the design. This figure here shows the distribution of the JUPEM tidal observation network. There are altogether 21 stations all over Malaysia, and JUPEM published the tidal prediction as well as the recorded tides annually for each of these locations, which can be purchased. Right now, let's take a look at the tidal characteristic along Malaysian coastline. As we can see here, at Peninsular Malaysia, on the west coast, the tides are primarily semi-diurnal from Selangor State northwards, whereas on the east coast peninsula, they are mostly diurnal from somewhere here, which is where Kuantan or Pekan is located, right? Whereas along the south, both east coast and west coast are characterized by semi-diurnal tide. And we can also see the characteristic in Sabah and Sarawak here. If we take a look in terms of the coastal climate in Peninsular Malaysia, the tidal range in the west coast is usually about 2 to 2.5 meter, whereas in the east coast is 1 to 3.5 meter. Meanwhile, the wave height in the west coast is lower at about 1.5, and the east coast is at about 2. During the monsoon season, the wave height may increase up to 3 meter in the west coast during southwest monsoon, and up to 4.8 meter in the east coast during the northeast monsoon.